Perfect. That's it. Welcome, everybody. I'm assuming everybody's in. Anybody who feels the need to wave hands, that's what the chat is for, chatty stuff. We also have, you will notice on your right-hand side, a Q&A. Questions during this session, please, in the Q&A. That said, welcome everybody to our second BoF on this topic, even though the title of the BoF isn't entirely the same. One has to drum a bit of a storm to get attendees. And I think we've managed to do that because listed as going to attend, we had 42 people, which is a great turnout. Who knows, there might be more people dropping in. Contrary to the previous time when we had to keep a list ourselves and ask people to register themselves on a Google Doc, this time around, I think the streaming platform will do that for us, so no need to do that. Everybody kick back, sit back, relax, as we take you through an hour of not so much speakers, that sounds too lofty, but fellow practitioners who share a common itch around data movement as they explain where they've been up to and what they're planning to do over the next couple of months, year. And then half a year for everybody in the audience to pipe up and say what sounds useful to them, what they might want to join, where they have suggestions, and what else to take up. We did list this in the both German word is Untitled for this particular BoF, that we would have two different items to discuss. First of all, simply informative, to continue the liaison between practitioners busy in the topic of data movement and data orchestration. And the second one, to identify whether there are joint items that we might collectively work on. But first, we have 5 speakers, practitioners raring to go. All of them have issued massive slide packs for 10 minutes each. So I should probably keep this rather short myself. And I will hand you over to Susan Border of the University of Michigan Library System on how big data movement is important to repositories and librarians, just as it is for big data practitioners themselves. Susan, ready?
Yes. Hello. Hi.
Take it away.
Yes, I am Susan Borda, University of Michigan Libraries, go blue. I hope everyone can see my presentation. Yes, thanks, Sarah. Yes, I see some thumbs. That's good. Okay, I will be talking about Globus, our use of Globus with our repository. Some may have heard me talk about this before. It's also a bit early here. I'm used to driving to the airport at this time, so it's kind of nice to be in my own home at the moment. Anyway, so good morning, RDA. Globus for repositories. So we will get a request. My group will get a request, an email or something, because normally we have a 5 gig limit for upload to our repository through the user interface. It used to be 1 gig, moved it up to 5, which is nice. So we will get a request saying, hey, I've got something larger than 5 gig. What do I do with it? How do I get it to you? And so I have some questions, that are relevant to this morning and relevant to our researchers. Where is the data and how large is it? Because if it's less than 15 gig, we'll put it on Box or, Dropbox or something like that to do the file transfer. But if it's larger than that, then I get involved, which is why I'm the data workflow specialist. I help people get their data from wherever it is currently to wherever it needs to go to be managed. And then irrelevant to this is what kind of data is it, but then where do they need it to go? Do they need it to go to our repository? Do they need it to go to a different repository? They just want someone in our group to look at it. And then ultimately, how do other people retrieve this data once it's in the repository? So where is the data? I'm sure most people in this room have encountered this. It's on an external hard drive, and yes, that's me in my hand. I got a call from somebody that they had a terabyte that they needed transferred to me. They didn't want to screw around with things, so I just walked over and picked it up and brought it back to my office. Still the fastest way to get a terabyte across campus. Is it on a personal server in their room? Is it on a lab server, centrally managed server, or is it attached to an HPC environment? These are all areas where people can have their data, and we can help them, I can help them transfer it. Enter Globus. Hello, Globus. It's been very helpful to me, to our group. We use Advanced Research Computing has the license at our campus centrally, and then the library kind of piggybacks on that use of our endpoints. But yeah, they've moved over 800 petabytes, so I think they can handle our low terabyte movements. We use them for file transfer. We don't use them for other things. It's available either through a GUI interface or through a command line. I primarily use it through the GUI interface. So this is kind of chopped up part of my workflow. We do not have a direct connection between Globus and our repository because our repository can't handle hierarchical folder structures. So I have to zip or tar or do some sort of manipulation to the files before I move them into the system. So also just getting it over and putting it on one of our servers allows me to review the data as part of the curation process. And yes, if you have questions, put them in the question area over to your right. So as I said, we use it for data ingest as well as data download. Data ingest, this is kind of our a schematic of our setup. You can see that that Globus fits between the internet and our systems. Because how do people access Globus, or how do people access our system? They use the internet, and that's how we have it connected in. It's not fully integrated for data ingest, but it is set up for data download, which helps us prevents us from getting into the classic, what I would call the roach motel for data, where data checks in, but it doesn't check out, which was a bit of a pickle we were in when I first started at Michigan roughly 4 years ago. We had a couple large data sets that there's no way how would you get that out of our system? We just didn't have a way to do that. And fortunately, fast and furiously, we put together this Globus integration for download. And so this is what it looks like in our system. This is just a snap of part of what the item view. And this is a 3.5 terabyte data set. The largest one I have is 16 terabytes. I also use a tiered storage structure behind the scenes. So not all of that is live in our system. Our system total at the moment is 25 terabytes of data. We have roughly 400 data sets. But anyway, so the process is someone goes into our system, sees that there's 3.5 terabytes of stuff there. How do they get that stuff? They can either click select an action and download an individual file or put that on Globus, or the snap is after I've pushed it to Globus. What I'll also do if something's particularly large, because it takes hours to move something that's 3.5 terabytes, even from one server to the other in the data center. So I will pre-stage something on Globus before I publish the data set, which is probably what I did with this one. So then it's already over there. They don't have to wait for it to be moved from production over to Globus and then pull it from Globus. Anyway, so then this is what it looks like in Globus. If anybody's ever used Globus or new to Globus, you have this is their, I guess their data management screen of sorts, where you have where it is to where you want to move it. So under the search panel on the right, I would have, somebody would have their local server or their local endpoint for the download. And that's it. I was pretty quick this morning trying to get this in before I go back to sleep. But anyway, this is the overview of my data workflow of working with large data sets. And here's our code if you are curious and want to plug it into your own Hyrax environment. We have it for, as I said, integrated for download, like it's actually part of the interface, but not part of the upload process. And if you need to contact me or curious, you have questions or whatever, feel free to shoot me an email. I actually talked to a number of universities about my process, a bunch of libraries about my process, because people are new to data sets of this size, and I'm using them all the time. I probably use Globus at least weekly, if not daily. So that's all I have, and I'm trying to desperately here to switch screens, so and cancel my sharing.
Bearing with you. Thank you very much. Thank you very much for that. Taking questions, but also, of course, ready to discuss these sorts of things after the initial run of speakers. So if anybody still needs to mull over precisely what they have to ask, I believe I see a Q&A come in. Yes. Can you say something about the uptake of Globus used for downloading data by users? Opt for that method, I guess, rather than direct HTML download.
Well, we don't have a direct HTML download for anything over 10 gig, because we had tried that initially of like, oh, well, could we do up to 20 gig? And we found that 10 was kind of the cutoff for us as far as being a real pinch point for download. We would get a proxy error, we would get all kinds of errors. So anything over 10, we shove it over to Globus automatically.
Yeah, there is. You have a duty of care as well, right? Where you can't really help people into bad behavior. Yeah.
Right. Well, the interesting thing is, I mean, I haven't run the numbers in a while, but we do get somewhat regular use. I mean, these are monster data sets, so they're not popular with the general public anyway, but we get enough regular use. The interesting thing is, though, is that we do have some issues with folks in China using it because of the Great Firewall of China, and also, oddly, University of York, someone there had a hard time downloading one of our data sets. So I do have a backup for some of our smallish, large data sets that I have a Google Drive as sort of a backup for those if somebody has a situation where they can't use Globus for whatever reason.
And as a yes/no question, are you using Dataverse as a front-end interface?
No, we are not. We are using Hyrax, Samvera Hyrax. We are not using Dataverse.
Okay. And I'm not entirely sure whether I'm unpacking this one correctly, but to compare this scheme of moving terabytes of data to somewhere where it can be used, which needs hours, as you say, compared to simply having it reside in a commercial cloud where you can start using it directly.
Yeah, we don't have a cloud setup for our repository at this point. I mean, that's a good idea. We do not. We are using local servers at this point, and we are not using AWS or anything like that.
Yeah. There is, of course.
We may do that in the future, but right now we're not.
In the generic case, it isn't a given that the compute that you want to do on the data set is available in the cloud necessarily. There's all this talk about moving the compute to the data, but that's not necessarily always possible. Where it is possible, by all means do so, but I think we have to prepare for a future. A lot of this BoF is about this. We have to prepare for a future where data movement will still be a current and viable thing for a while to come. Quotation and funding of compute, of ubiquitous compute everywhere, is not trivial. In fact, that's a great bridge into the next speaker. In fact, next speaker up, Martin Barisic. I'm hoping I'm pronouncing your last name correctly. From CERN, one of the developers on the Rusho project, but CERN in the capacity of being very busy of trying to make sure that the infrastructures they build are useful for other big and mid-tier data and compute science cases as well. Is that enough of a bridge for you, Martin?
That's perfect, yeah.
Beautiful, take it away.
So, let me share my slides. Let's see if this works now. Okay, that should be full screen now. Does this work? I assume yes. So thanks for the introduction. Welcome everyone. My name is Martin Barisitz, and I'm the project lead for an open source scientific data management tool, which is called Rusio. And just to give you what Rusio is in a nutshell, it's essentially a system which provides a modular scientific data management federation. So at the root of this means it connects and integrates scientific and commercial storage resources to one federated namespace. And that's really the most important part of it. You can really freely choose the storage solutions your workflows and your use cases need. That can be storage in the cloud at the usual commercial cloud providers. It can be some storage you run in a data center. And in the case of high energy physics and the CERN use cases, it can be highly distributed storage landscape. And all that is then presented to the user in one single global namespace and can be accessed by the users and by third-party applications in a very controlled and efficient way. The whole tool has been built on more than a decade of experience we have in high energy physics here at CERN. So with the classical particle physics use cases. And now more recently, we are kind of bringing this tool to other sciences and are going through an adaptation process, so to say. So most importantly, Rusio is really used in what we call the full data lifecycle. So from the creation of the data at the experiment, in our case at particle detectors, then to the registering of the data with metadata in the catalog, transferring it worldwide, using the data, and finally deleting the data once it is not necessary anymore or once it is not used anymore. And this is being done with high level, both high level and low level policies, which the user and the administrators are free to choose. The whole software is open source. There's an open development community behind it. And to show you a little bit quickly the history where this comes from. So it comes from the Atlas experiment, which is a particle detector. And all these particle collisions are being recorded and then put into Rusio for then later on storage and further analysis. And this is quite large numbers. So currently we store somewhat of 550 petabytes of data, more or less, and more than 1 billion files. And this is highly distributed. So this is 120 data centers of all sizes. There's some very large ones, and then up to much smaller data centers from universities who only pledge a small amount of resources to the experiment. There's also high performance computers, there's commercial clouds, and the user statistics are somewhat around 500 petabytes of data are transferred per year. And then another 2.5 exabytes of data are locally accessed at the data centers or at the cloud providers. But now, more recently, we are essentially breaking out of these high energy physics workflows. And that's where the ESCAPE project comes in. So ESCAPE is a European project under the Horizon 2020 umbrella. And the goal here is really to look at use cases from the different sciences. So this is partly also CERN experiments, but then also experiments from the astronomy domain, from other physics use cases. So you can see them here at the left side. And then also from the infrastructure side, from data centers who then provide these infrastructures. And here the idea is really to look at this from a use case point of view and not strictly from an infrastructure point of view. So we really look at what are the workflows these sciences need and essentially use these workflows and use cases to drive the development of the infrastructure behind. And this is all done having these fair data management principles in mind. And where we end up then, especially in the changes to Rusio, is the ESCAPE DIOS, which is the data infrastructure for open science. And here the idea is really to deliver a data infrastructure which then can be used by all these diverse science projects. So really going away from the non-high energy physics specific implementations to a more modular ecosystem which really serves all these different science use cases. And this is done by consolidating these use cases and then using these findings to drive the development of the infrastructure and also of projects like Rusio. And Rusio really stands as the data management tool at the center of this. And where we ended up at is to change Rusio in a way where it's really modular, and you can essentially enable the system or tools in the system, modules in the system at the level where you need it to. So at the center of it stands a horizontally scalable catalog for files, data sets, metadata, and so on. And then you can, on top of this, further enable further functionality based on your scientific use case. So of course, this is transfers between disk systems, tape systems, high performance computers, different commercial clouds. Then there's this whole AI authentication layer on top of it. And this drives it then further into monitoring policy engines where you kind of can express your data management needs and have the system automatically enforce it. A completely automated stack of data corruption identification and automatic recovery. And then really the last use cases are then data analytics monitoring tool, which analyzes the usage of the data, and then this creates additional data replicas as needed based on the data use cases. One thing which is important to mention, Rusio is not a distributed file system. It really interconnects existing storage systems over the network and presents to the user a federated namespace. But it's also very important to say that you don't need to run Rusio software at the specific data centers. So you run your storage at the data center, you publish the ways of interacting with these storage systems to Rusio, and then Rusio takes care of the rest. And the important part here is that this really frees up the infrastructure providers in choosing the technology which best fits essentially their use case. I already mentioned Escape, then there's a much wider landscape of projects involved. But it's important to mention that this is not only a tool for these very large sciences like Atlas or CMS or astronomy experiments like SK, but also for smaller sciences, since they also have quite significant data needs and also need to essentially have a tool to handle their data. Yeah, and now I'm already at the summary of it. So Rusio is a reliable, open, and efficient data management system to support a wide variety of science use cases. There's a strong cooperation between physics and now many more scientific fields, and these science use cases really drive the development of the software. And this is now available to use and really for anyone to benefit from these advances in both we make in the scientific data management area, but also in more of the industry-facing advances, especially in commercial cloud providers. Yeah, thanks a lot. Oh, I also put a last slide with some information if you're interested.
Beautiful. I'm presuming I'm new to this platform, but we at least as the BoF organizers and speakers will do everything we can to make the slides available. I don't quite know how this works on this platform, but we will make sure that this works. Can you take two questions, Martin?
Yeah.
Easy first one. Is Escape working with Archiver?
So not that I know of, but I can get this question to the right people, but I'm not aware of that.
I do believe there is a link. in as much as I've been, but I mean, Escape being very much a build it yourself stack, and Archiver being very much a try to outsource it. So there are connectors. Archiver defines an API on the consumer side, and provided escape talks to the API. And obviously, a lot of what CERN tries to do is expunge data held in EOS into the archives. So the API will definitely work towards escape. It's not being actively used yet, but there is coordination between the two projects. Sorry to take the question for you. And he's one from the...
Yeah, I mean, maybe...
Yes, go ahead.
Maybe important to mention, I mean, Escape is a big project. I'm obviously more focused on the Russia part of it. But yeah, it's a much larger project.
Yeah.
And there's...
And one, as a clarification, you had 500 petabytes on slide 4. Is that per week or per year?
That's per year.
All right. Whew. You guys are weird, but not
of transfer,
you're weird,
yeah.
but not that weird, right? All right. Beautiful. So compare and contrast. So we've now had two speakers from the communities and science practitioner side, people with requirements. We're moving to a talk from the science infrastructure operator side, Lars Fischer, Norgenet. Obviously, there is synergy, right? In as much as science cases can define and build up the stack as they want to run it, some of them, maybe the extremely large ones, such as CERN, excluded, who can be both a consumer as well as an operator. But in the mid-tier, it's important to make science cases understand that it's not required or necessary that they operate their entire stack themselves. There are operators available, willing and able, not for profit, tasked and mandated to do these sorts of things, to pick up these infrastructures, provided they get sufficient requirements from the community, this being you, right, in amongst others. And Lars is one of these people. And if he's ready, and I've seen him test his interface a number of times, you stalker, you, then you can take it away. You good?
I hope so. The first test is, can you hear me? You can.
Right. I can see you.
Good. Now I will test if I can share my presentation. Okay. No, I am not allowed to do that. Oh yes, there we go. Are you seeing anything?
No, we don't see the presentation.
Would it help, Lars, if I shunted to another presenter just shortly while you take a moment to figure out how the screen sharing works?
Get an error. Guido, I'm going to have to ask you to get that presentation and share it, if you can do that.
Andre, are you ready to take the next slot?
Can do that. So let me see if in my case different.
Perfect. We'll give Lars a few minutes to do that. Are you ready to take the next slot? Okay. So instead of Lars as an operator, we have more operators. More operators who might. This is a battle between who's most digitally dexterous. So in the left-hand corner, EGI winning out over Norgenet. Andrea Manzi, who on behalf of EGI, the European Grid Foundation, is also inspecting the merits of running a data transfer service, and I believe standing one up or investigating standing one up for EOSC Future, but that ought to be enough of a bridge again. Andrea, you good?
Yeah, thanks a lot. So good morning, everyone. I think you can see my slide, no? So it's fine. I'm Andrea Manzi from the EGI Foundation. That I'm going to describe a little bit the services in EGI related to data transfer. We have, so first of all, just describing a little bit what is EGI. So it's international infrastructure providing computing and data analytics for science, and it's governed by a council that is made of composed by 22 countries at the moment, and different international organization. And the EGI Foundation, where I'm working, is the coordinating the infrastructure. The services that I'm going to describe today are partially funded by a project that I started this year, the EGI ACE project. So just to give you an overview of this, it's a project that's been started in January, implementing, as I aim, is of the project is to implement the computing platform for the European Open Science Cloud. And the aim is to deliver integrated computing platform, data spaces, and tools as a solution aligned with the major Cloud Federation project and HPC initiatives. We have the services that are operated in AGI and AGIAs are in this ready to data transfer are in this picture of the service architecture, are in this federated data area. So basically, AGIAs is based on a set of federated resources, which delivers like compute and storage facilities. We started this year also with the project to have like also HPC pilots in the context of AGI, which they were not there before. And then, we have this federated access layer, and part of this federated access layer are the services operated for data transfer and data management, which I'm going to describe later. And then a set of platform services, and which are integrated by communities, which are going to integrate them in some thematic services, data space, and early adopters. And these services then are going to be delivered to EOSC users via the EOSC portal. The communities that are part of the project are coming from different domains. So we call it like data spaces in different domains, like I said, in environmental science, energy physics, energy and physical science, climate research, health and medicine, and also we have early adopters, which will also part of the project and provide some services integrating, the tier architecture that I showed before. We have the communities, not all of them, but most of the communities that part of the project have data transfer requirements. First of all, some of them, they would like to distribute experiments or data for resiliency and archival in different sites, implement also data placements that orchestrated by data management services, and if possible driven also by workflow management systems, which also implements the asynchronous movement of compositional outputs. And of course, one of the main use cases is also to have to transfer efficiently data set that's stored at central repository to end user. This is what, for instance, is one of the use cases that's presented by Susanna at the beginning. We also have Rusio that's presented, by Martin before. So this is something that is the first time that is operated by AGI. This service is, as described by Martin, has been developed at CERN, but then it's been integrated by different communities also outside the domain of energy physics. And internally is used FTS, which is also another service that we provide at AGI for data movement, but it can also be integrated with Globus as well. And it's in the case of AGI, it's operated with some extensions. So we have not a dedicated instance per community, but catch-all instance, so a multi-community, multi-VO instance that is operated in the context of the project, and it's being extended in order to be interfaced with the workload manager that we use at AGI. As I said, Rusio is interfaced with FTS, which is the low-layer data movement service also implemented at CERN. And this type of service provides some functionality and features that are, that implements, for instance, checksum and retries per transfer. Implements also a support for different protocols, so it delivers like a multi-protocol support, and this is quite important because it's can be interfaced with the different types of storage that are available in infrastructures. Of course, optimize the transfer scheduling in order to optimize the usage of the network without overloading the storages, or providing, transfer classification per priorities and activities, and it is integrated by different data management systems, of course, including Rusio, that, as we said before. There is also another service which we have in the context of AGI, which also deliver data transfer functionalities. It's called Data Hub, which is based on the One Data technology. And in this case, the service allows the transparent data access under a common space, both open data or restricted access to member of community. And in this case, the service allows the replication of data between data providers. It's not as we said before for the other type of services that it can be interfaced with existing storages, but it needs a gateway to be installed by different facilities. And in this case, the replication can be executed on demand or automatically, also based on the quality of service rules. And it's used mainly to expose existing data sets and also to implement data caching at compute facilities. But of course, it's also mentioned here because it implements also data transfers, and in some use cases is used also by AGI communities. We also have, outside, of course, of the context of the GIFGH projects, we started last year to discuss with the Globus in order to, which of course has been presented also before, so I'm not going to repeat, the possibility to have a Globus, European Globus instance federated with the US one. Of course, this will require, quite some investment for the implementation for the federation, and we try to understand also from the EU communities the possible funding and the interest, of this kind of type of service deployed in Europe as well. This will be a long-term activity, and for the moment we are planning, and we are discussing with Globus to provide initially support for the European users that are using the service, which both free users or users that are under subscription, and possibly also starting a kind of reselling role of Globus to some European communities. So as a conclusion, I say that basically a lot of communities are using the AGI distributed infrastructure for computing and storage, and the AGI ACE communities, that these data spaces that I mentioned before, a lot of them have the data transfer requirements. We believe that, of course, by operating, these sorts of low-level data movement services like FTS is necessary in order to optimize the usage of the network and also avoid the overload of storages that are behind. And for this purpose, we also deliver and we operate, with this new project Rusio, which is offered to the AGI communities, and can be interfaced also to FTS and Globus. And we are trying to push the existing and the new communities to converge to the same data transfer technologies. Not one, but we have like some subset of them, and in order not to, of course, reinvent the wheel, and to have like us operate the services for the communities, and to optimize the data transfer and the data placement on the infrastructure. And thank you. So I think that this was my last slide. Thank you. I can stop my sharing, I think.
Yeah, beautiful. Thank you very much. If at this point in the talks there are members of the audience beginning to wonder whether the speakers are colluding to make sure that only Rusio, One Data, and Globus get a Guernsey, that isn't in fact the point. The point is that there really isn't a plethora of choices. Tools out there capable of dealing with large data movement without excessive license fees, sort of therefore fit for big science, there really only are a handful. So what you're hearing here isn't people colluding, it's simply people individually having made the same choices. So let that be both an incentive to the audience as well as a warning. Don't go blundering out there yourself and hoping that you might be able to fix this by cobbling some tools together. That tends to catch fire and fail. Sorry, I sound like a schoolmaster. Lars, it looks like you've been able to... Oh, Jan, you're doing it. Ah, it's the Nordics helping each other. Fabulous. So Lars, can you do video as well? So Lars is on video, Jan is on slides. So this is collusion. This definitely is collusion.
Yeah, there
I
is
referred to my previous intro. Lars, go for it.
Yeah, thanks. So we've heard a number of use cases here, and we've heard from very impressive stuff going on in physics and astronomy and things like that. And we've heard EGI sort of on the computation and storage side of things, working on data movement. In the NRENs, the research networks, we are traditionally all about connectivity. Next slide, please, if you can. So I am from Norginet, and Norginet is the network that sort of is an international arm of the national networks in the 5 Nordic countries, so Norway, Sweden, Finland, Denmark, and Iceland. And we were very proud of having a very, very high capacity, extensive, all these nice things we like to say about our research infrastructures, network in the Nordic countries, of course, providing multiples of 100 gigs everywhere, going terabit soon, already working with some instruments in providing terabit services, and also having an extensive global footprint. We have 100 gig connectivity to places in Asia, to North America, and we can sort of we peer with every single every ISP out there. We can do all the global the commercial cloud services. We can sort of, our aim is to ensure that there are no man in the middle, that from a Nordic NREN to any other NREN in the world, we can take the traffic there, right? So we have this very large network where we talk about reach and bandwidth and capacities all the time. So that is what we think of traditionally when we talk about what an NREN is. So next slide, please. So next. Yeah, so I shouldn't have done the animations when I didn't want to do the presentation myself. Anyway, so traditionally there are 2 pillars of a RNE network. One is to do trust and identity, so managing single sign-on and roaming, user login and things like that, making sure you can all use your home password to log into the EGI or the Xiang or whatever it is web pages. The other is connectivity. So we are about connecting institutions to the internet. We talk about bandwidth, we talk about capacity, we talk about speed. What we do is essentially links between A and B and forwarding IP packets. That is what an NREN is all about. And we, we used to be very proud when I started doing this about having megabit capacities. Then we were proud about having 40 megabit capacities, 100 megabit. Now we are proud to soon do terabit, but it's essentially unchanged except for the numbers being different. Next. The thing that is in common with these 2 things is that we address data indirectly. We don't really work with the data of the users. We just provide sort of the underlying tools that allow somebody else to do something with the data. We provide the infrastructure of identities of people so that you can make sure you can build your own tools to make sure you have the right people getting to your data. And we provide the links and the packet forwarding and the high capacity so that you can move your data if you know how to do that sort of thing, as EGI was showing before. And one result we see of that is that networks are often not efficiently used. I might be able to provide a multiple 100 gigs of capacity between a Reykjavik University, or Icelandic University in Reykjavik, and somewhere in Germany where the Ether store their data. But it turns out that when a user in Reykjavik tries to get Ether satellite data from somewhere in Germany, they aren't getting gigabit capacities. They're getting a few hundred megabits of transfer speeds, because there's lots and lots of protocol layers, or the way people are doing it, or they're using a web browser to do their downloads, or whatever it is, and it's not very efficient. So there's a sort of discrepancy between the capabilities of infrastructure we provide and the actual benefit that the user are getting. Next slide, please. So next, what our user wants are traditionally, or when we talk to users, what is it you want? They don't want capacity, in fact. They don't want high-speed links. They want their data in the right place at the right time. they want the right data to get to the right person, and assurance that it's getting to the right people. And they want to manage identity and access so that they have control over the groups. They're part of the data and the data objects and the facilities that they're getting to, so all the identities of all these things. So that is what we are hearing as requirements, not really sort of just the low level of components to put all this together. Next, please. So it's the same pillars. It's all about capacity and packet forwarding and trust and identity and some security. But the emphasis is different. It's actually not indirectly on the data, it's directly on the data. It's about moving named data objects. It's about orchestrating data in time and place. And it's about having the capabilities to do fast, secure, and reliable data orchestration, so that if you have an instrument, you have a data archive, you have a compute facility, the data can get from your instrument to your compute facilities to your data archive at the right time when you have scheduled your compute hours and so on and so forth. So that is really what we should be providing, and not just this primitive low level of thing that is sort of the same internet that we were providing in 1991 or something like that. Next, please. So if we start to rethink the NREN network, so this is from a session I had with my own network, so the 5 Nordic NRENs some time ago, where we talked about, so what is it we should be doing if we look into the future? So we say that we facilitate data capture and movement and access to our researchers, for our researchers, anywhere where they are, where they work. Next, please. And next. So when we think about the future of networking as ResearchNet, we still think about upgrading to terabit capacities, but we really think about how modern research is based on complicated workflows where data is produced in one place and processed and stored in separate locations by teams of researchers that are working together. And our role is really to make sure that researchers have all the tools they need to do the right types of access management, to do the right types of group management, to link their home account to their supercomputing site accounts, to their instrument accounts, to make sure this is transparent and that it sort of is ubiquitous across all the platforms they're using, and that you can talk about named data objects. I have not these files I want to FTP, but that I have this outcome of a observation of the night sky with the European Southern Observatory, and I want those observation files or those observation outcomes to be at my archiving site or at my compute site at a specific time. So we want, to name objects and to have them moved and orchestrated to be where we need them to be. Next, please. So also in sort of the larger European context, we are currently among the European NRENs preparing for the next stage of the Xiang networking and the Xiang network projects. Traditionally, the European Commission funds sort of in 7-year cycles upgrades and work on the pan-European network platforms. And so then the previous one was called GN4, or the one we're current now is called GN4. So the next one with with the traditional inventiveness of the European platform, we will call it GN5. So we're kind of working on drafts of sort of the high level goal for GN5, and in those drafts, there are words again about we need to evolve this, what we call the European communications platforms, toward data-driven research and education. We are realizing that research is kind of inherent data-driven, that education is data-driven. And so the long-term objective of a collaboration like Xiang should be to be this partnership that allows R&E communities to integrate their data sources and to move data and orchestrate again that data are where it's supposed to be at the right time. So again, this is sort of changing the way research networks like NordGNet, like Uninet, where Jan Meyer, you'll hear from in a moment, is from, or like Xiang, are thinking about what is it we are doing, what is the infrastructure we're doing for. It's not just for forwarding IP packet and using your browser to go to Google, it's for orchestrating data. Next one, please. So inference network, research networks, they will still be about terabit networks. We will still do lots of complicated engineering to deliver very, very high capacities for big science instruments and all that kind of stuff. We will still do trust and identity and make sure you can have your digital identity. We will still focus very much on making sure it's secure. But in order to generate value for user communities, the focus must be on data movement, on data orchestration, and no, this is not that we are going into data management. It is just that we are sort of moving a little bit up the value chain to not just look at forwarding data packets, but actually orchestrating data to be in the right place so that the people who do data management can use these tools to make sure that they can move and orchestrate the data. I can't remember. Is there one more? Yeah, so for us, in addition to making sure that that users get the tools they need and can organize and orchestrate the data in the way they need, it is also very much about making sure that the networks are used more effectively for users, both individually and in groups, that by using tools that are built to leverage gigabit or terabit networks, we make sure that when users do the data orchestration and data movement, it is actually happening at terabit speeds and not at megabyte speeds, as we way too often see now. So we will have to work with infrastructures like EGI, with supercomputing sites, with campuses to make sure they have the bits and pieces in place so that all this can integrate and work across the entire ecosystem where research happens. So I think that was the last one. It was. So thank you very much.
Many points for good improvisation. What a bit of synchronized swimming, gentlemen. Well done. There is one question which, in the famous words of, I believe it's Feynman, isn't a question, but somebody pointing out they love the link between Longyearbyen and Ny-Ålesund. I think the people who dug the line weren't that happy about it. Was it cold stuff, right?
So no, but one of the it's I think Jan will soon also talk about this, right? So one of the differences between a research network and your local ISP is that your local ISP, if you buy your summer home up in the mountains, they can tell you, no, we don't do broadband up there, it's too far away. Research network doesn't do that. We are here to allow researchers to do research where research happens. So if people decide to sit somewhere crazy in the middle of the Arctic or in the Greenland ice sheet, we should make sure they have the capacity they need in that place, right? So that is also part of orchestrating the data. Is not just orchestrating the data where it's nice for us to orchestrate it in a data center somewhere in Central Europe, but to orchestrate it where it actually is and where researchers are working, like in Longyearbyen and Ny-Ålesund.
That wasn't an obfuscated way of you explaining how you got your summer home wired.
Citizen science.
That is exactly what
I am taking notes. All right. And on that note, so are the gentlemen swapping? So Lars is now doing the slides for Jan, or is he capable of doing this all by himself?
No. We have long ago realized that it's very, very good that I am not trying to make a living working with IT, right? I can't do that.
Your IT provider, gentle people. All right. Next up, Jan, also long-standing member of IT R&E service provisioning, but himself a tool developer too. I wonder whether that might feature in the slides, but over to you, Jan.
Thanks, Guido. So I'll pick up where Lars left off. So Lars basically presented the change in thinking that we're having, but from a very high level. So I'll try to take you through our current thinking. All right, so it's a nice vision. Now, how can we actually make it work in practice? Because that's what we're all about. So I'm Jan Meyer. As Guido said, I've been working in R&E for over 20 years, and I have activities in various places. One of my hats is that I'm the chair of an open source effort called FileSender, deployed in many European countries for the transfer of files. I work quite a bit on making commercial cloud services available through EOSC and the NRENs. And I've started thinking about this. And the reason why I guess we're all starting to think about this is because it itches. I hear Susan talking about getting exercise because it's still the quickest way to move a terabyte around. And it won't surprise any of you in the audience that similar stories are heard far too often. Far too often it's like, well, we hired a car to transfer a bunch of disks because that was the fastest way to get X terabytes around. And so, as Lars pointed out, despite these fantastic R&D networks that we have and their global availability, it's still not easy for most researchers to move even smaller amounts of larger amounts of data, like hundreds plus of gigabytes, terabytes, let alone petabytes around. If you're lucky and you belong to the CERN community, then you have a well-developed and well-funded apparatus to support you. If you're unlucky, you don't have that and you're stuck. And when we have networks capable of terabit speeds and you can't even easily transport a measly terabyte, then something is wrong. So that needs to change, obviously. It's not a simple challenge. There's a large number of people involved. In Europe alone, we're talking about 1 million researchers in academia spread over 3,000 institutions that you need to serve. The volumes are also steadily increasing as all research digitizes, and whatever instrument someone uses, they then tend to generate more and more data, be it €1,000 gene sequencers or people deploying wildlife cameras with 4K capability. All that stuff generates more and more data. So the problem is exploding. Now, how could you address the problem in practice? Well, how did we do that for the network? What makes the network a proper infrastructure? It's proper infrastructure built on a common view. It's ubiquitous at a global scale. So it's available to everyone across the globe. You don't really have to think about that. It's easy access for all. It used to be harder, but that's 30 years ago. Nowadays, you have your good campus infrastructure, you have EduRoam, you have mobile connectivity with good peering agreements, making it very easy to basically transport bits from anywhere to anywhere. It comes in all flavors and sizes, from small to very large, to address any use case that you can imagine. And you can use it whenever you want. You don't need special hand-holding unless you have something very, very special that you need to do, in which case the hand-holding is available through a well-built-out support infrastructure that's both well understood and built out on all the tiers, all the way down to the individual researcher, through NREN, campus, faculty, section. The whole thing constitutes of a federation of networks with each administrative domain, so every constituting component, be it campus or be it national or regional or European, each takes care of its own turf according to the needs it has, the budget available, and the priorities that that local community has. And the local priorities will obviously be different for an entity like CERN than it would be for a smaller campus. And there's expertise globally available. There are people available who can make a career out of being very, very good at engineering this stuff. Now, there's a common view available. It's kind of, it consists of blueprints. So we have blueprints for most of the standard ways of building networks. If you want a campus network, there's a way you can do that. It describes what bits and pieces you need, what componentry you need. You know where you can get those components, and you know how to glue them together to build a functional network. This is not the case for data movement. As I said, some people are lucky that they have services available, but it's by no means an infrastructure that's available for all. Now, where would it be nice to be like 10 years from now? It would be nice to have like a proper data movement infrastructure that has the same characteristics as the network has, that makes it really trivial for any researcher to move data. for anyone, anywhere, anytime, and any size. It should be simple and secure, support both ad hoc and orchestrated, make sure that my data is at the right place at the right time. And it should be a ubiquitous, well-supported standard offering that can service the vast majority of needs without any hand-holding or specials, but that can still provide specials where needed, because after all, we're servicing the research community and we go where the research goes. And I tried to summarize that in this little diagram, as so it's by no means intended to move too far up the stack. It's basically built a little layer on top of the network that supports the movement of data, which then allows the people that want to do stuff with that data to just go ahead and do that without worrying how they get their data from A to B. So how do we get from products to infrastructure from a little bit of a pragmatic point of view? I think I should have lifted out one or two components of this particular thought. So one thing I should mention is that this is by no means a greenfield exercise. As we've heard previously in the session, there are a number of tools available that do a good job at doing these things. So in many ways, this is a challenge in organizing much more than it's a challenge in building new technology. And the approach that we're thinking has merit. We're starting with a position paper now that'll basically describe a problem statement and project a possible way forward, which we believe should consist of a roadmap and lead up to a blueprint, which people then can start to implement. But the important thing is to get a common view and a common terminology in place and a common understanding of, okay, so what is that infrastructure and how do you build that? So a small group of us is currently working on that position paper as a preparation for the next generation big NREN collaboration project that starts in 1.5 years and runs for 7 years. This is an open invitation to join the effort. So we're very keen on hearing, right, is there merit in the vision? And if you have any ideas on how to progress that vision to something that is actually implemented and usable, then by all means, please contact us. Thank you. Is there still anyone here, or am I the only one left in the building? There he is.
The platform requires you to click 4 or 5 different things before you turn on the video again. No. In fact, you've got a couple of questions. Can you see the Q&A yourself, or do you need me to read them out?
I can see the Q&A, but I don't know exactly which Q&A pertains to. Okay.
I'll start reading them. I'll start reading them out to you. One of them is in typical Feynman style again. Isn't a question, but it's a statement, although it ends in a question. A problem might be that researchers and projects take the network for granted and then don't push sufficiently on the national level with the NRENs and national funders to improve the network. I guess what the question asker means is to improve the network up the stack. Is there a way to get researchers and representatives of relevant projects more involved in the lobbying process? I'd argue, I'm taking the question from you, that's what we're doing here. We too, as NRENs, we need to articulate the entire case, not just the infrastructure and the bits and the pieces and the copper. We need to articulate that there is a scientific requirement and a question and a community of practice behind it that we need to take to our ministries, our miners, etc. I'll hand it over to you, Joe, though, Jan, if you have anything to weigh in there.
No, I think you're on the mark. So what we can do is we can try to formulate a vision to solve a problem, but the only way that we're actually going to get funding for that is if we can communicate clearly that there are people that actually have this problem.
Yeah, exactly. Historically, there's been a bit of a divide between upper layer stuff like data at the data collection layer, at the metadata layer. There was good representation, RDA, CoData, etc. The very bottom, building networks out of boxes, well articulated, well funded, but in the middle where the two come together, it really was only done well in some small disciplines. CERN, astronomy, some of the early genomics and climate science stuff like Susan explained. But by and large, there is a bit of a lobbying disconnect, a bit of a representation disconnect, which we're trying to solve here. We should be humble. We're trying to solve it.
So, yeah, I just thought, so to address that question, so that's exactly the reason why we're writing that position paper at the moment. We're writing that position paper to basically crystallize the vision and crystallize a possible way forward so that other people, including ourselves, but also very much the research community, can take that and, if they buy into the vision, can use that to lobby to, for example, research councils, national ministries, whoever funds people who can contribute to building that infrastructure. And that infrastructure is not going to be an NRAN-only infrastructure. That doesn't make sense. Different communities require different service providers that provide services to them. But what's important is that it's a coherent, total global infrastructure available to everyone.
If I can just add to that, right? So I think, I know every country is different, and in some countries you may need to reach out and put some, pressure on your funding bodies. But I think from research communities and from users, it's also important to actually engage with your provider, right? Because we have, and I can say that because I am from a network, we have this tradition of we built very, very high capacities and we sort of throw them at a campus, right? Here's your 500 gig connection, and then we walk away, right? Expecting them to do something good with it, right? In just about the same way we did when we had just invented the internet 20 or 30 years ago, right? There is, except for the capacity being higher, we are doing very differently in that respect. And it might be good to start from a user and from a researcher point of view to say, guys, that isn't good enough. I'm left alone here with my 100 gig connection, and I have all these complex needs, and nobody seems to be taking care of that. So we are expecting more. We are expecting better service than just 100 gig and figure out for yourself how to transfer all your files to the right place with that. So I think rather than just pushing on the funders, push on your network provider.
But the entire articulation needs to start happening. Volker, happy to see you join the chat. I think we're sort of unofficially shifting into the actual BoF mode now. I can see the questions pouring in. I warmly encourage people to join and turn this into a lively debate. Turn on your microphone when you need to. I believe there is a protocol. Maybe the RDA people could explain this in the chat a bit better, but there is a notion of putting up your hand, but I'm new to this platform as well. Anyway, that's enough for me. Talking stick to Volker.
Yes, so I fully support this point. You have to. It's great to work on a position paper, but then the initiative has to come. If we want to fund something on a national level, it has to come from the researchers in the countries. Some things can go through GEANT, but not everything. I mean, we have to have the support and the pressure, and usually we get lots of pressure on the infrastructures in terms of computing centers and so on. We don't get so much requests saying, okay, we need within 5 years so and so much network capacity. So this has to be communicated back, perhaps through RDA, to the individual members, saying, okay, your project has to make clear how much network resources they need.
Yeah, but that part of that is chicken and egg, in that because it's so hard to move seriously large data sets at scale, people resort to LAN and a VAN, if I'm allowed to make my own joke again, sneaker net, whatever you want to call it. And therefore, the demand on networks from the mid to long tail isn't that high yet. There's a revolution waiting to happen here. I'm going to attend to a few more questions in the chat. One beautiful curveball I believe it's for you, Jan, putting aside the delays caused by protocols, are we anywhere near the limits of photon speed on the networks? If you don't want to take it, I'll take it.
Not as far as I'm aware. It's been a while since I've last done the calculation, but shouldn't you be able to transfer like 5 terabytes in something like 6 minutes at like 100 seconds? So it's nowhere near. No.
Yeah, it has very capacity it doesn't have too much to do with photon speed. It has to do with frequency. Our capacity to modulate light waves fast enough. That is the problem at the moment, and it's growing. Networks sort of have their own Gordon Moore law. Roughly every 20 months, the speed doubles. So honestly, physical network capacity is not the problem. Our problem is tooling. Hope that answers the question. What else? Where's the bottlenecks? Gosh darn. I'd say tooling again. Tooling, and once the tooling is in place, probably some outreach, some word of mouth, some training. But tools can be made easy enough to be used in more or less a click and drag fashion for the earliest adoption. It's just that there aren't any infrastructures in place to keep that sort of tooling up and running and reliably delivering to all of the capillaries across the world. I can see it. Peter, you're welcome to join.
Yeah, so I'd also say it's the availability and the organization of making the tooling available, because the tooling is clearly there, right? CERN is doing this, except you need a CERN to do that. And CERN doesn't scale that well globally, I would imagine.
No, are their own operators, and it's not necessarily geared towards all use cases, right?
Exactly.
The Escape project in that respect is,
Yeah,
Leandro has asked you if you could please type an email where people can start collaborating on the position paper. I suggest you do that in the chat. There's a question on how the network topology can be better aligned with research topology and how RDA can help. This is going to sound massively jaded, but that isn't really the problem. There are fibers to almost every campus and every sizable instrument that we know about. And those instruments that haven't been fibered are complaining bitterly, so we know that we need to go there as well. If you do have a massively large data source or sink that isn't known to us, first of all, talking to your campus people, they will find us. That honestly, physically delivering the fibers isn't the problem. I believe. I know it sounds jaded. If you do, I'd love to see counterexamples. But it honestly is. It's tooling and local awareness typically. Were there other things that I forgot to canvas here? Exciting challenges, practical challenges. Thoughts on load of the target infra and the destination of data, impacts on job running on the target, interoperability between different storage technologies, as those are real challenges. That is very wide. Roberto, if you have a chance to join us on audio, I'd love to hear you about precisely what you mean here. Not all data movement is necessarily from one HPC center to another. You know, there's a lot of mid-tier, middle-brow. Certainly the data sources don't. Perfect. There you are. Talking stick over to you.
Yeah, thanks. So what I'm thinking is when it can be quite simplistic because I got to move hundreds of terabytes of data from A to B, right? And I need them by a certain time. Except that one has to consider the target, the destination of your data, what's going on there, not only in terms of user jobs, but also in terms of system jobs. Because that data transfer, that movement of data itself, if it's not carefully managed, can severely affect the system jobs, which can affect the performance of your destination storage infrastructure. So I'm just wondering, have these thoughts been taken into account, and any thoughts in mind how to address them, especially when you are transferring between different technologies, because there are different mitigation techniques between source and destination, right? If you're using, I don't know, one vendor, different vendors essentially, right? There can be interoperability issues. So I'm just wondering what thoughts are there.
If Martin or Andre are still online, I'd love to hear you weigh in on this one.
Yeah,
this is the. Yep.
I can also add a little bit to that one. I mean, if you right now the way usually we transfer data is completely sort of independent of each other, right? If I have a petabyte file I need to move from University of Copenhagen to University of Stockholm, I will start a job to do that. I will not be aware of any other use of the network or of the local resources at either the endpoints or anything like that, because I'm just me. So one of the advantages of moving towards a data movement infrastructure is that you hopefully can get to a point where the data movement infrastructure is aware of other things that is going on and is actually getting instrumented feedback from the underlying infrastructure, from the network, knowing the capabilities, knowing the load on resources, so that it can better stage the transfers or make sure things are not done that are conflicting with each other, right? So it's another reason to move up the stack and not just talk about forwarding IP packets, but instead talk about orchestrating data at the right time, so that you can combine several transfers in an intelligent way, right? There are lots and lots of capabilities in programmable network. We'll not go there today, but you know,
Okay,
Andrea?
thank you. Yeah.
Yeah, I want just to add that if you use like a loaded movement service, like for instance what I presented before, FTS, you will have the possibility to instrument the service in order to share the load of the users on a particular storage. So you're not like partitioning the transfers that are going to a specific storage based on organization, and not like try to avoid the overloading the storage by one community only. So this is possible, usage of the service that would be fair, among the different communities that are using a particular storage technology. In this case, this is what you said, that you have problems of sharing storage between different communities. And then about the interoperability, of course, there is some. We need to in our case we need to agree on which kind of protocols mainly to use, not in which kind of technologies, storage technologies, because different storage technologies can have the same protocol for transferring data. And in our case, practically speaking, we have like, for instance, grid FTP, which is the most common used, but then, we're moving towards, HTTP as well. So it's, instead of like interoperability of storage, I think it's, we should, use and focused and on the same protocol to be used for transferring data. This is, if you want to have like a global, of course, infrastructure. For data transfer, basically.
Hans, glad to see you join.
Hi, I must say that I'm a retired person from a computer center from Polar Marine Research, and I just wanted to, say the word of caution that in my experience, users are first of all not aware of the limits of their own resources. Like you can expect people to plan for transferring a petabyte of data on their laptop, things like that. And also they are majority of them, except perhaps for high-energy physicists, not able to plan or say in advance what they actually need when. I have had this experience not so much in networks or planning in the network usage, but usage of tape storage, for example, when we told people, well, yeah, you can stage your data, set the whole of it from tape to disk by saying so. There's a command line interface for that, but nobody did. They simply used single data files, which tended to overload the tape drives and so on, because they didn't do it in a bunch, in an ordered bunch, but singularly. So I added the word of caution that, well, you shouldn't plan to move data anywhere, but anywhere
where it makes sense. Yeah. There is and this is going to sound slightly Darwinian almost. These capabilities are beginning to exist, and those science cases that figure out how to deal with them will do faster science. I'm not saying better, but will do science faster. You can see this happening around genomics in particular. There are still people who do genomics in a bespoke style. put the sample in a sequencer, press the button, get the terabytes on your memory stick, and then start hand tinkering with it. And there are groups who are doing this large scale with automated workflows. And you can simply see that the latter type of group is beginning to attract more funding, more students, etc. So we can do two things, right? As infrastructure providers, we could either go, we could take the Luddite route and go, oh my God, this is going to put so many people out of a job, it's going to be horrible. And this is shotgun science, etc. Or we can go, look, we can make the tools available, and those groups who are capable of dealing with this sort of stuff and wish to outsource the management of that sort of data management to, I'm going to say competent, that's self-congratulation, but to a qualified group of people. I don't want to be in a place in 10 years' time where people go like, we could have done better science if only we were able to use tooling and orchestration without us in our relatively small discipline having to provide career paths and having to ask for funding for the millions of euros that it takes to build these sorts of things for a bespoke vertical only for our... So I'm totally with you. And in the chicken and egg sense that people right now aren't even aware that this is a thing, they're not schooling themselves, they're not training themselves up to be competent users of this sort of stuff. But I don't see a future in 10 years' time where there are many research disciplines left that don't at least use some of this sort of capability. But the caveat is completely taken on board.
Yep.
Training, awareness, and really simple interfaces. Command lines will not cut this.
No, exactly. And to what Hans was saying there, I agree with Hans. But if you ask users to operate on a too low a level, where they have to deal with individual files and tape drives and all kinds of stuff that has nothing to do with what they're actually trying to do, yes, they will end up doing unfortunate things that are not productive or not efficient. So which is why we should provide better tools so users don't have to say, I want to transfer all these files from these tapes to these disks and whatever it is. They should be able to say, I have this named data set that is an observation of the night sky over South America at this particular time. I needed this compute center to be computed on by this resource I have. And then the tools should understand about tape drives and all this stuff. That's the one thing. The other thing,
about limitations, right?
The real dream is even one further. The real dream is one further high up. You have a workflow. You say the next experiment I want to do is compare the following things. I want to compare this data set with that data set.
Yeah, exactly.
You schedule the thing. Underneath, a system needs to realize, wait a minute, I ain't got that data set. I'll start looking for it. Eventually, in the best of all possible, if we end up with Apple science, I science rather than e-science, researchers won't even be aware of where the bloody data set is.
No, but the other thing,
because they will be aware of where the data set has been funded.
Yeah,
right? That will always.
The other thing to what Hans was saying is this worry about people trying to move 5 petabytes onto their laptop. Yeah, there is that. I'm more worried about all the users I see. And I really see that happening a lot, where people say, oh no, my data set is 100 terabytes. You can't possibly move that from Sweden to Italy over the network. I'll have to send a hard disk. Because that was the message they had from the university in 1998. And they sort of still think the same thing. And when they tried, they will use some bad tool where they FTP'd from the laptop, and they will realize the performance is bad. So nobody is helping them to realize that, yes, you can move petabytes. And you can do it quite efficiently, even intercontinentally. And I think that is where we have to get. Right.
But I want to add, Guido, that's what you described as a vision about planning for scientists. That is the absolute minimum, but what must be possible, because what's actually happening now in earth sciences already is that people notice that there are so many data sets available at Google, for example, in their Google Earth engine, that they simply move their own data there to merge the data sets and so on. And so the real competition is not between, it will not in the end not be between the naive users who are trying to do impossible things, but between whatever we as a community set up in the public domain, let's say, versus what's possible in commercial clouds. Including the availability of data.
Yep. Yeah, and to a degree, that's even a question or a conversation we need to have with funders and policymakers. What is the future you envisage? Are you okay funding research that then moves the data sets to third-party commercial providers? I'm not saying it's either good or bad. I have my private opinions, but funders need to realize that that is a decision they are making de facto. If they're not explicitly making the decision, then it's being made de facto. And by us collectively, not just the operators, but also science groups and operators who are interested in this sort of mode of moving forward, if collectively we can at least argue that there is a credible alternative, even though it may not be at the scale of Google, but you don't have to sell yourself out in wholesale. There are credible alternatives, provided we have funding, a community of practice, and credible policy that provides longitudinal cohesion. This needs to be done for funding cycle after funding cycle, right? If you say we're going to do this for 3 years and then we will see again, no scientist who's worth their salt will move to that infrastructure, right? They will just write it out. But if you as a funding body and a policymaker can say we plan to do this for the next 10 years, then most people will swallow the bitter pill and realize, there's something to be done here. But yeah, absolutely right. It's not purely a tech journey, not at all. In fact, it's a journey of communities here, which is why we're keen to engage with RDA. What's in it for Google? Gosh darn.
What's in it
if
for
you
Google?
own all the data, then more data will flow, right? What's in it for Facebook?
And then it attracts processing, right? Have data will process. But so the position of the commercial cloud providers is that from a societal point of view, it should probably be a good hybrid situation. You don't want to end up in a situation where like a big three providers basically host all the research data, especially if those, from a European perspective, if those providers are non-European providers, that wouldn't be too good. And if you look at all the policy documents and the plans around Horizon Europe, words like data sovereignty, there's a lot of them, of that word. So it seems to point to that we're starting as Europe to take data sovereignty more seriously. And then you have to ask yourself the question, as Guido pointed out. So, right, when you use public funding, where do you want the data to end up? And it might be acceptable that the data ends up for convenience with the commercial provider du jour that you happen to have an agreement with. But ultimately, you want to have your data in various other places as well. And I briefly mentioned it, the provider du jour. Well, the other thing that's going to stand in the way of just pushing all to commercial providers is the Public Procurement Law. And the commercial providers are very unlikely to host all our research data for free. So someone has to pay for that. That has to be procured. And from time to time, you have to shift supplier. And then it's really convenient if you can actually realistically do that. And you won't be able to do that without the data movement infrastructure. And even so, on the scale of Europe, with the amount of data that's being produced, one or two providers gobbling it up all, I doubt that that's a realistic scenario. But it's an interesting point. And to the question, to a related question that came up, how does Amazon deal with that? Well, they ship you a container and then you can transfer it to that, and then they truck the container out. That's how they move exabytes or petabytes around.
Yeah, in and not out.
Yes, in. Yeah, because out costs.
Yeah, if there is a comparable example in the commercial world to data movement at scale, it's not so much the big cloud providers, it's the big CDN providers. Good at this game are Netflix, Spotify perhaps as well, streaming at YouTube, which is of course a Google platform now, but has its own way of operating, right? There are YouTube caches you will get positioned in your network if you do this at scale. We're kind of suggesting that is the sort of infrastructure that needs to be put in place for science as well. Not just endpoints, but caches, middle boxes, anything to tool this up. We're coming towards the end of this BoF. I wanted to, first of all, thanks to all the speakers, thanks to everybody who weighed in. I wanted to close off on a couple of notions of where should we take this, because I'm more than happy to host another one. There is plenty of work still going on, even if we keep to this to simply liaising with RDA and explaining every half year where we're going, and then taking this offline and progressing it in our own individual fora. But if there are people who want us to progress particular things or make sure that we prepare a particular statement or body of work for the next RDA, or think that we ought to take this to another level, now is your chance. Now in the next 5 minutes, I think. Or of course, ping us after the session. Our email addresses are available. But we are very much wanting to take this to a practical level.
May I say something about?
Yeah, of course. That's the whole point of a BoF. Yes.
You see, I've been member of RDA from Göteborg on, and I think that this vision of a narrow bit of infrastructure between the network and the data management infrastructure is quite appropriate and very important, because the data management systems normally don't recognize these limitations of networks and things like that. And I particularly found, it was new to me, this Ruscio vision, if not implementation, very interesting, because it brought in all these problems, including moving data on disk, which we did, by the way, from Polarstern when it drifted along the North Pole to land, right until up to the CDNs and so on. So I think there is definitely a place for a statement or whatever, and it would be very important then to network such a group and such a recommendation with the next layers represented in some of the RDA groups. So that could help very much and avoid the reinvention of wheels by data management software things, which has been mentioned, I think, by Martin.
All right. With that, I'd like to say thanks all. Hope you have a very happy. Yeah, well, I'll hang on for that. More hearts, more hearts. Thank you all. Have a very happy RDA continuation of the conference. I'll be around at the very least. We are pingable on email addresses. We are very Googleable. See, we don't hate the cloud providers. It's all fine. And open for suggestions. Can't be curveball enough. Thank you all, and I'm closing this BoF.